Question number 9 deals with e, which is a number that we don't see very often. This might be the first time you're seeing it. Now, e is very similar actually to pi. If you look out in the hallway, e and pi are painted out there, and they go on for a very long time. They are irrational numbers. That means they never stop, and there's never a pattern with them. 3.1415, it just continues on forever. But they're very important. They actually show up in weird spots. You'd be surprised to see how often they show up in math. So the mathematician that did a lot of work with this, his name was Euler. Okay, it looks like Euler, but Euler is how you pronounce that. I believe it's German. I would have to double check. He's a really interesting fellow. He did a lot for math. He was super smart. Anyway, the number that we are going to be using is right down here. It goes on and on and on. The only part of that you really need to remember is 2.7. If you can remember 2.7, you know e. It's a nice approximation, and we're just going to be multiplying by that number. Okay? If you look at our equation back up here at the top, e to the x. Another way you can think about that is y equals 2.7 to the x. So this is our base. That's what we're multiplying by. It's our pattern. So we aren't doubling, we aren't tripling, we're somewhere in between those things. So let's just do a little bit of math with that to show you what's happening. So if we choose a value of -1, of 0, 1, 2, and 3, we are basically taking that and we're saying, hey, e to the -1. That also just means 1 over e to the first, which is 1 divided by 2.7. We'll figure that decimal out in a second. 1 divided by 2.7 is 0.37. And I'm fine if you're estimating, so 0.37 right there. Then we have to take the next one, e to the 0. Now this should be easy because anything, even 2.7 to the 0 power, is 1. I can take 1,000,000 to the 0 power and it's still going to be 1. Here, I have e to the first. Well, that's just e, which is 2.7. So the answer there is 2.7. If I take e squared, e to the second power, that just means 2.7 times 2.7. So I'm just multiplying as I go along. Literally, I could times 2.7 by that answer, and I get 1 times 2.7. I get 2.7 times 2.7. Just keep going. I get 7.29. And then if I take that answer and just times 2.7 times by e, I get 19.68. Again, that's e to the third. That's 2.7 times 2.7 times 2.7. 19.683. All right, now this is kind of an estimate. If you do this in your calculator with the actual number, these will be slightly higher. So now it's when I need to graph it. So -1 comma 0.37, going to be right over there. 0 comma 1 is right here. 1 comma 2.7 is slightly under 3, and then 2 comma 7.29 all the way up here, just a hair above 7. If I look at the next number, that's almost at 20. Too high. I can't quite get there. Now, if we go back to the graph, this should make a little bit of sense because I'm getting closer and closer to an asymptote. The asymptote for these are centered at the origin because I didn't move it anywhere. All the way up in the equation, there's no shifts, horizontally or vertically. So my star technically is right there, which should make more sense because there's a 1 in front, so my initial value is 1. And that's actually what some of these things are going over. So the initial value, what's in front of the 2.7? A 1. Is this growth or is it decay? Because it's 2.7 inside, it is growth. That is my growth factor. E means I'm growing. The asymptote here is right on the x-axis, so it's horizontal. Y equals 0 is its equation. The domain, all real values from -infinity to +infinity. And then the range, or the y values, I'm limited. I can't go past the asymptote. So that says from 0 all the way up to infinity, or you can use an inequality, one of the alligator symbols, y is greater than 0.